Hello, TriPass. Thank you for having me along for your meeting this time. Spoken with Tracy and the other folks there, and asked a few months ago if I would join up and talk with you all. And so I've got this session I'm really passionate about, and so I thought we'd just jump right in and be part of this. And I really appreciate your involvement in the community. I lead the community for SQL Server and Azure Data here at Microsoft, and I run the Tampa SQL user group with a friend. So very passionate about this area, and you're making a big investment in your career, even by just being here at this event today. So let's get started. I'm going to share my screen out here really quick. What we're going to be talking about today is something, as I mentioned, that I'm quite passionate about. Um, the thing I'm passionate about is actually data literacy. And it's more important today than ever. And I've always been passionate about this particular topic, and we'll talk about what data literacy means here as we sort of go. There'll be no slides today. I'm going to give you all the resources that you're seeing on the screen. I'll give you a link that'll get you to everything you need to get to, and so on. That'll take care of getting you all this material. This is a full hands-on workshop. It can take 8 to 9 hours to run this thing, or even longer. The other thing that's interesting about this particular workshop, and it's all free, everything in here is free, is that it actually has hands-on workshop stuff that you can do, tasks you can do. And this is suitable for high schools, which is where I teach it a lot, all the way up to the C levels, CEOs and CTOs. As data professionals, we often think we're really good at being data literate, but in today's environment, with artificial intelligence, generative AI, and all kinds of other things, with fake news and all the rest that we have in the data sources, it's more important than ever that we all understand how to work with data. And you can see there in the title, it says, using data to make intelligent decisions. Well, what I'm going to do is just pop down into this workshop. We're not going to use any slides. We're just going to use the workshop itself. Let me make it a little bigger so that you can see it on the screen. Hopefully you can see that there in the back, and that's okay. All right, so what is this workshop about? Well, basically, it's using data to make intelligent decisions. It's wisdom. It's applying data correctly. And this thing starts at the very basics and goes all the way through machine learning and data science. So we're going to do an audit of this course in the next little while here. We've got about an hour. We'll probably go a little less than that. But again, I'm going to give you this resource so you can go do it yourself. Two reasons I'd like you to use it. First, I'd like you to go teach it. If you don't mind, if you have a career day at your schools, your kids' schools, or you don't have kids, grab a school and offer to teach them this course. Tell them you're a data professional and you'd love to go through this course. I've taught at community centers. You can actually teach it at your local city's community center. Do that. Have it at the library on a weekend, something like this. Very important. Again, we need people to be data literate, especially today. The second part of this is you might not know everything that's in here. A lot of times, as data professionals, we start working on our day to day. We know what we know, the things we've had to do, but there's little corners of the data world that maybe we haven't been involved in as much. And so we may have a few deficits in our knowledge here to where we don't know everything we should know. Hopefully, this will fill in some of those corners. I'm hoping you know 90% of what we're going to cover today, but you may not. You may surprise yourself. You may learn something. We're going to cover some tools and things too, and they're all tools you can use. You can even use some of these tools for free. We'll talk about things like Excel. We're gonna of course hit Excel, and you can actually use that just if you have a standard live.com login. You can, or Microsoft.com. You can use it. Most people can get a hold of Excel, and the dirty little secret is everything I show you in Excel can probably be done in a lot of other spreadsheet programs as well. All right, so you'll notice there's a bunch of resources as you go. So it's always a good idea to right click things and open in new tab. You'll see that that's kind of how that's done there. So if you right click and open in new tab, that's better than opening it directly in the tab, which I'm going to do, but we'll show that. All right, this is what you'll learn how to do. You're going to find and source the most authoritative data. This is super important. Normally in our data professional lives, we don't have to do this. We're given the data we work with, but in some cases, you may need to start finding and sourcing it. I'll show you how to do that. We'll talk about some data tools, some very basic ones. Then we're going to learn how to analyze data in context. That's important, that last part. And then we're going to talk about how you create analytic results from that data. There's a bunch of things here you can read over about what we're going to do. We're going to learn about spreadsheets, the SQL programming language, and in our case, T-SQL, right? We're going to talk about the R platform, the Python programming language, RDBMSs, relational database management systems, NoSQL databases, which I think now stands for not only SQL. I think that's the new politically correct way to say that. And then we're going to talk about some data science tools and platforms. You need a local system where you can run software. You can do this on a Chromebook or a phone for that matter. You could, but it's better if you have a system where you can install software or at least access the web and use web-based software, which is completely okay. I do expect you know some basic math, addition, subtraction, multiplication, division, a little bit of algebra, maybe some logic if you remember any of those things, but I don't say that you have to have this PhD in statistical analysis. Although I'm going to give you some information and courses along the way for free. If you don't have something, don't be embarrassed about that. Go learn. Whenever you don't know something, don't be embarrassed. Go learn. There's a prerequisites document. You can go read more on that. This tells you more about the workshop. There's also some related workshops you can go learn more. And here we go. We're going to first start with finding and sourcing authoritative data. And we're going to learn how to do that properly. Next, we'll go to data tools, then analyzing data in context, and then using data for intelligent descriptions. So, a decision, excuse me. Next, you could go to the prerequisites. We're going to skip that for this particular thing. I'm just going to go ahead and jump right into the first module, which is finding authoritative data. Now, what does this mean? Data is the basics. It's the oil, it's the water, it's the bedrock of what we do. And we have to know that that data is authoritative. We talk about here that basically, if you think about data itself, we can think about data as being almost the letters of your alphabet, whatever language you happen to speak. It's the letters of your alphabet. And that forms an atomic datum, or the base unit of your data. We'll start with that idea as our basic idea around data. And then you learned, as I point out here, with paper and pencil, those were your tools to learn to write. And then you learned, and that's very similar, by the way, to the tools of programming and the Excel and the other tools we're going to be using. And then you learned the rules of grammar. And grammar is how you put the letters together into words and then the words into meaningful sentences. And then you were able to read a book and make an intelligent decision or follow a recipe. I like baking bread. I don't know if you're into that sort of thing, but I like reading the recipe and making the bread. And this is basically what we're going to be doing here. So what's data? We have to start out with a definition of terms here. Factual information such as measurements or statistics used as a basis for reasoning, discussion, or calculation. Notice there's a hyperlink here. Everything I've mentioned in here, I try to make sure you can go find out more if you'd like to. So once again, right click, open in new tab. So we're going to talk about two basic types of data. First, there's quantitative data, and then there's qualitative data. And qualitative, by the way, is often in statistics called categorical data. And basically, there's a long definition if you want to go read that. But if you think about it, quantitative, quantity is how much, and then quality is tell me about it. It's a description of what it is. And then you might think, of course, I know this already, Buck. Why are you showing me this? Well, we have data types in SQL, so we have a lot of them, actually. We've got 30. And using those in certain ways actually is important. When you think about it, in statistics, we don't understand the word red. We don't understand the word apple. We don't understand any of those things. It's numbers. Those other words, red and so on, are called categorical. They're just bins to collect other numbers. But in data science, when I'm doing machine learning, as we'll talk about in a few moments, I actually need numbers. I can't use words like red. Like in a database, we would have a column, color, red, blue, green. Okay, that's the easiest way to store that. But in data science, I can't do that. I can't perform a math algorithm on the word red. It doesn't do anything. So what I do there is something called one-hot encoding. How weird is that? But basically, I do a pivot table and I take the colors and they become a column with a value. So red gets a 0, blue gets a 0, and green gets a 1. I would know now the thing that we're talking about is green. And now I can do something with ones. I can calculate vectors and I can do predictions because I've done this. So right here at the very start, when we're talking about what the data types are, the type of data that we're talking about in data literacy is not SQL data types. It's literally quantitative and qualitative data. All right, so then I've got a little exercise here where you can begin to set some of these things up. We're not going to do the exercises, obviously, today. We'd be out of time very quickly. Now, here becomes the most important thing, I think, in today's world about data is source identification. You've got a bunch of links in here that I've got, and I want you to open each one of these because finding authoritative data is a skill. And it's an interesting skill because like newspaper reporters or researchers, this is a skill they develop a lot. And we sort of take for granted. We do a quick web search and we come back and we're like, yep, that's the truth. But we don't know if that's the truth. You have to actually figure out if that's an authoritative data source. And so I've got a link here with starting how to have a basic understanding of doing research. Remember that from school when you had to learn to do research at the library? At least that's the way we did it when I was young. We still had card catalogs when I was a kid. So you had to go learn how to use the library. We had a library day where you went and learned how to use it. But there, the librarian would actually explain to us the process of research. And that is super important. You also need to understand the difference between primary research and secondary research. Primary is when you go out and you look at the apple and you say the apple is green. Secondary is when your friend goes out and looks and comes back and says there's a green apple out there. And that's quite literally how this sort of works as we go. So we need to know the difference between what these are. Now, by the way, I've got some of these things on here. Even searching with the web, I don't poo-poo that. I don't say that's a bad thing to do. It's a fine thing to do to use the web to research things. It's the primary place most people go these days. Shouldn't be the only place you go, but it's a primary place. However, there's some advanced searching techniques in all of the major engines. Google or Bing, whichever one you kind of gravitate towards, or if you're using DuckDuckGo or any of those kind of things, they all have a page that explains how to do advanced searches on there. So I use a lot of times I'll type in a topic and then I'll type site, S-I-T-E, colon, Microsoft.com. And I know that will limit the search to only the Microsoft.com site. So that's very useful for us to know. Okay, so then we have an activity here for you to go locate some data about a topic. And we're not going to do that, but here's some interesting ones. Locate the unit sales of lipstick for the US for this year and compare it to the sales in 1947. How many sources did you use? Did they agree? What would account for the discrepancy? And how would you report that back out in your analysis? And you said, that is a really weird thing to ask. Is it though? The pandemic reset the world. And one of the biggest hits was clothing and sort of cosmetics because people weren't going into a common environment. Why get dressed up if you're not going out, right? So you'll see that this has reset. And actually, the cosmetics companies had to figure out what are some new ways to make things easier or whatever so they can retain their sales. And the sales have changed. So when you go back in, you may see some surprising things about the difference between lipstick sales in 1947 and in 2023. So it's kind of interesting. Then I wanted you to learn to use more than one source. That's the important thing you need to do. All right. Then we move on to verification. So once you find the data, there's three sort of vectors that a newspaper reporter might use. The first, is it accurate? Is it representative? And is it sufficient? In statistics, you must have these things. Accurate just means is it closely aligned to the reality of what happened, the observations, we call these in statistics. Secondly, is it representative? If I go right over here down the street from my house and say, hey, how do you like pizza? And I ask 10 people, and these people go, oh, yeah, it's fine, whatever. And I report back, hey, this is everybody likes pizza. you should immediately ask the question, how do you know that? How do you know that? And when you ask that question, what should respond back with is, I asked a lot of people and they told me that. And which people, where are they at? Are they in China? Are they in the US? Are they in Guatemala? Where are they? Who are they? Males, females, young, old, different races, different genders, different, what is it, right? And so we have to make sure it represents the thing. This is kind of interesting. I did a study the other day, and I found out a large portion of the car sales, the vehicle sales in the United States of America, is the Ford F-150 pickup. Not just any pickup truck, that one. And I'm not advocating whether you should have a Ford F-150 pickup or not, or even a Ford, or even a car, but that's what a lot of people drive. And so one kind of interesting surrogate for how representative your population that you're asking questions from, the sample we call it, would be, do you drive a Ford F-150 pickup truck? If nobody says yes, you're probably not representing most of the United States. Isn't that a crazy thing to think about, a car question having to do with a sufficiency question inside statistics? But it's true. And then next part is sufficient there. We have representative, then we have sufficient. Have you asked enough? 10 people is not a sample. Not if we're talking about how many people like pizza. Well, you just don't know. You'd have to ask a lot of people. And there's even formulas you can use, by the way, to tell you this is a sufficient enough sample and this is a representative enough sample. There's not really a formula to find out if it's accurate or not. Unless you had both sets of data, the accurate data and the non-accurate data, and you could calculate something from there. Okay, this is something, my three questions that I always taught my daughter when she was young, and she knows this to this day and has taught it to her students. She's a school teacher. Whenever anyone tells you anything, including me or anybody else, I told her, always ask three questions. Who's telling me this? What's the source? And then secondly, what are they really saying? Right? And then three, why are they telling me this? Right? Because I asked or they volunteered. This is a fantastic car and you should buy it. Interesting. Who's telling me that? My friend or the salesperson? That sort of makes a difference, doesn't it? What are they telling me? This is a fantastic car and I should buy it. That's kind of interesting. Why do you think I should do something as opposed to not do something, right? So we go from there. And then why are they telling you this? Well, if it's the salesperson, I think we're pretty sure why they're telling us this. They want us to buy the car. So you always use these three questions. It'll keep you out of a lot of problems. And if you just ask them, you'll find out some stuff that's there. And you could do that for qualitative and quantitative data. And I also have a reference here. Let me open this one. Let's pop over to how to be a data skeptic, not a cynic, but a skeptic. I don't really want to save any money, but there we go. I save so much money right now, I can't afford to save any more money. All right. Here we go. Exceptional claims require exceptional sources. And we call these exercises and we look at some red flags. I also give you in this first module here some government guides, US government data, Google's public data forum, open data initiative, and 5 more data sources online. These are really useful. I use the CIA World Book and Fact Book all the time for things when I need demographic data, all kinds of things. I will say this. I have found some of the most accurate data that there is when something deals with money. If somebody's got to pay for something, they tend to have fairly accurate data. So financial sources are a wealth of information. In fact, I don't watch the news, but I do listen to the financial news because you'll know what's important. It's not the rescued puppy down the street or the terrible thing that just happened in your city. Somebody wants to make money off of that. And so that's kind of where you pick that up. All right, here we go. Let's now move on to our next topic, working with various tools. So now we found our authoritative data. We know we can trust it because we've done all of our checks and so on. We know the difference between quantitative and qualitative data. Let's go to the stuff everybody always thinks about when we think about data literacy. We think about various tools. You can work with your tools. And by the way, you can use everything from paper and pencil all the way up to some very powerful tools that we'll have. But the very first one, of course, is the spreadsheet. And the spreadsheet is one of the first things that went to computers, and it was one of the first things that went to mini computers, and it was one of the first things that went to microcomputers, or PCs, as we now call them, back in the day. So I've worked in all of these eras, and everybody likes columns and rows. And in fact, ledgers before that were the precursor to spreadsheets that we use today. They're one of the most handy tools that humans have for working with data. These tend to be what we call structured data tools. What does that mean? What's structured versus unstructured? Well, technically, there's no such thing as unstructured data. It's got some sort of structure. It just doesn't conform to a rigid set of columns and rows. We often call those, by the way, a schema, and you're familiar with this word, obviously, as a data professional. So the schema we know is columns and rows. Columns we sometimes call attributes, rows we often call tuples or whatever. So we can go through all these things in a spreadsheet, and it's one of the best things that you can do. We also call this, by the way, tabular or table type data, tabular table. And we tabulate data, meaning to calculate it in some way. And basically, there'll be a heading. Sometimes there's a heading at the top and on the left for a heading for the rows and columns. The intersection of those often called a cell or a datum or a particular value of a particular area. All right. And it can also hold a formula. In Excel, we start the formula programming. If you think about it, Excel, when you're using formulas, is a kind of functional programming. If you know the differences between object-oriented and other kinds of programming, Excel is actually a functional programming language. The formulas and macros that it has there, they start with equals, and then you can begin to perform calculations on rows and things. And you should always know how to use spreadsheet. I think I taught my daughter. There was a business book of I've forgotten the name. I think I listed down in here. It's one of the few paid for resources that I like it so much that I've put it in here. And I would pay my daughter $10 if she would read it every year. And so starting at like 10 years old, I started indoctrinating her on Excel, because I know if you can do Excel, you can get a job. There's a bunch of them that are free as well, by the way. If you're new to Excel, there's a full section here. Complete this section and bookmark it. There's all kinds of things you can do. One of the most powerful parts of Excel that we'll leave off on here is a pivot table. Pivot tables will help you understand that it's not just the pivot table itself, which is quite powerful and quite useful. It's more to it than that. The pivot table is actually more useful conceptually than just what you can do with it functionally. All right, great. All right, we know how to find data. We know how to work with data now a little bit with paper and pencil. And now we have some electronics, and we begin to use the things in Excel. And I'm going to show you that reference that I told my daughter here at the end. Now we move over into the structured query language, or SQL. Our dialect inside SQL Server is called Transact-SQL, and Oracle has one, PL SQL, and so on. All of them have different dialects of these, but they allowed you basically to do what's called a CRUD operation: create, read, update, and delete. That's what you can do with data. Now, interestingly enough, we talk about a relational database management system, or an RDBMS, and we're going to talk about that in just a moment. A lot of people make these engines, and these are our first levels. With Excel, you're not really multi-user, although multiple people can hit Excel at the same time online. It's not really meant to be a multi-user system. Relational database management systems are. SQL is the language that allows you to extract that data out. It's a calculus. It actually came out of a relational calculus back in the late 60s. A guy named E.F. Codd, C-O-D-D, created a system to solve a problem we had using COBOL flat files. COBOL was a language, common-oriented business language. And basically, we would take these files, text files, and we would encode them with just regular old text. We put a number to the side, and we try to kind of link them together, or we denormalize them into these long rows of data and so on. All kinds of problems there that we had. We had the whole acid property problem. What does that mean? Atomicity and consistency and isolation and durability. We had these problems to where we couldn't guarantee that the data was correct. That's the easiest way to say it. So he said, wait a minute, what if we just broke this up? What if we made a calculus out of this? And we could put things down one time and one time only, and then we could sort of point to them with the calculus. We call this a join. And so he invented this idea of normalization. Normalization. Well, what is normalization? Well, normalization is simply breaking down the data into atomic units. And you can do this very easily if you think of this little rhyme. The key, nothing but the whole key, and nothing but the key, so help me cod. The key, the whole key, and nothing but the key, so help me cod. And basically what that means is I'm going to give each row of data a unique identifier. And you could think of a number, but it can be anything. And I'm going to give it a unique identifier that has nothing to do with the data, nothing at all. It's not natural, because there could be more than one Buck Woody, although that would be really bad. But there could be more than one Buck Woody. So we'll give that line another number that if you add it all together, just that number only means that row ever. And so that was the key. The whole key means I should be able to identify that row just by looking at the key, and nothing but the key means that's the only thing that identifies it. I don't use other things to get in there. If you just get to that third normal form, it's called, you're good to go on your data. It goes much higher, but third normal form is fine for most of us. All right, what does all that mean? Well, basically what that does is it allows us to work with these objects, a database, which is just a single collection of data managed and stored in a single way. A relation, interestingly enough, did you know relational database management system doesn't refer to the fact that things are related? Tables are actually called relations in relational calculus. A relation is a table. So a relational database management system is something that works with tables. It has nothing to do with the joining between them. We do have a tuple, which is a single collection or a row, an attribute, which is called a column or a query. There are other words, by the way, for these tuple attributes and so on. And then the query part we're thinking of is SQL. All right, then we're going to go find a system. There's a full reference you can have. Let me just pop over to it. And there's a full introduction to SQL from W3 Schools. And I really like this. And the neat thing is it's also got sort of a linter built right in. A linter is a thing that can evaluate a language and make sure it's correct. And it sort of simulates that you're running on a real database. This particular one's not. It's just simulating that you're doing that. So that's the first one I'd like you to do, is just make sure you know SQL. I think everybody in this room today knows SQL or T-SQL, but I recommend you pop over and take a look at that course and see how well you know SQL. Always something new to learn. All right, now let's talk about R. As time goes on, we've got these languages that will help us work specifically with statistics. Now, statistical analysis, absolutely huge. It's a big deal. We're going to talk about statistics here in just a little bit, but it's a big deal to be able to work with it. There was a language called S that went with a company called SPSS, which is actually still around. And this system allowed you to do these coding words that were functional in nature and would return results. Well, in Australia, there was a group of college teachers, and it was too expensive. It's very expensive to buy this program for their students. So they said, why don't we, from the ground up, not copy this thing, but make our own language, and we'll call it R instead of S. And so they did, and the R consortium was born. R has then taken off. It's an open source product, meaning it's free and you can use it wherever you'd like to do, and you can contribute or take back from the source that's there. It's a functional language. And basically what that means is you use expressions, not statements. And I'll leave that there. We'll go from there. It is also read right to left. This is my left here, right to left. So basically, you'll see in R all of these arrows pointing to the right, and you can think of that as the word gets or takes. So if I see, there's an X here and it's got the arrow, which is just a greater than symbol and a dash, and 10, that means X gets or takes the value of 10. I now have a variable called X, and I can say X plus X equals, and it will tell me 10 or 20, excuse me. And then you can then say Y equals X plus X, and that will be 20. And now, I have two variables, X and Y, and so on. It's a fascinating language. And then it's got lots and lots and lots and lots of functions built right in to do statistical things. It also has libraries or packages that you can install that have more functions. And there's something for if you design plumbing systems, I kid you not, there's an R package that will help you calculate the bends in the pipes that you need to get the water to the right place. It's stunning what's available in R. And I basically explain how you work with this, and I've got a reference for you here. Let's pop that one over just to see. This one's from Code Academy and is really well done. This is also, it keeps trying to offer me to save money. I don't know, again, I can't really afford to save any money right now. Now, R is a fantastic language used by millions of people around the world, still very popular, still very useful, highly recommended. It's one of the ones I like. And by the way, if you know SQL, it's pretty easy to learn R. And then we move to Python. Now, Python is interesting. It actually started out as more of a sort of a scripting language almost, but it turned into this object oriented, and you can even do functional if you wanted to inside Python. And it's pretty simple to learn, and it's very powerful, and it's become the standard language in data science. Now, there's other languages, Scala, Java even are, and other languages you can use in data science. That's fine, but you'll see a lot of stuff done inside Python. Once again, it follows a simple process called the PEP of the Python Enhancement Proposal, which is just a correct way of writing a Python, but you can write it badly and it will mostly still work. But if you follow these guidelines, which are pretty simple, you'll write some really good Python. Python also has the ability, and so does R, of making some beautiful visualizations. And I use these quite a bit. And I use them inside something called a notebook, and we'll see what those are. You can learn these, by the way, if you know SQL, you should learn R. And you should learn Python. Even if you just play around with a couple of toys systems in it, you should give it a go. So in this exercise, you'll do Python, and I've got MySQL on this particular one. You can use any database. There's all kinds of connection libraries it can use, but this one uses something real quick. Then there's a couple of resources you can have here for free. Now, let's talk about tools for storing and processing data. First of all, you just use regular old text files, but you should know a little bit about text files. You should know the difference between an ASCII file, just a plain ASCII file, or a comma separated file, which is an ASCII format still, but is separated in a certain way, tab separated formats. You can see JSON, XML, all kinds of other text or ASCII encoded data. Still very useful, something you should know about, and you should know how to work with it. I've got a couple of little things here that explain sort of how that works. Something important to note, something called delimiters, and these are things that separate the elements that you want to store. All right, we talk about XML. Don't make that face. I still love XML. I think it's a very useful thing to learn, but you can take a look at this. And by the way, you can store all of these data types inside SQL Server. And I've got a whole bunch of things about XML here. Then we start talking about key value pairs. These are very important in NoSQL, or not only SQL databases. They use these a lot. And there's even certain parts of that. The NoSQL can actually use things like what they call documents, which might be a JSON, JavaScript Object Notation, JSON files to store data. And here's an example, and this one shows an example here from Wikipedia, and I cite my sources because I try to always do that. So you can kind of read through that, and then you can work with JSON from there. Now, when we work with these things, we normally relax consistency, meaning that you might read a file, I might change it, and you still got it. So it's no longer accurate. So we're not consistent with each other. If I try to write back, it's a very big possibility I could either step on something you've done, or you could step on something I've done, meaning it's not isolated either. And it's not very atomic at that level. So relational database management systems were created to respond to those issues, the idea that there's not full ACID compliant systems. So the first thing I'd like you to do is go out and you've got two, by the way, that you can read about, but I've got a big 9-minute introduction to database engines that I highly recommend you take a look at this video. We're not going to do that right now. Now, while the RDBMS tightly controls your full ACID properties, your atomicity, consistency, isolation, durability, the availability part, the CA, consistency and availability, are always fighting with each other. Consistency means it's the same everywhere. But availability means I have a lot of everywheres. And the speed of light will prevent us at some point from being completely C and completely A. And so this is called the cap theorem, meaning you can't violate the consistency, the availability, and the, don't worry about the P at this point. But the point is, we always fight against those two. A relational system is considered to be highly consistent, but not as available because it's harder to scale that. A NoSQL system is said to be very scalable, so it's available everywhere, but it's always not super consistent. And sometimes you don't need to care about that, and sometimes you do. If we're running, say, a bulletin board system where you're making comments, if it's not consistent, it's okay, but you do want those comments to keep showing up quickly. So you'll see those used in NoSQL. All right, so there's obviously a whole bunch of these. There are document databases, column databases, key value databases, distributed cache, and my favorite lately is the graph database, which I've been using quite a bit with some other work I've been doing. So there's a whole thing where you can go learn more about those. Each one of these is a free resource, and there's a video that you can see. Now we start talking about reporting the data. So now we've stored it, we've potentially processed it. Now we need to report it back out or query and report it. So there's a couple of things you can do inside Excel all by itself, and talks about charts. There's a full set of resources for working with these charts and pivot tables and pivot charts. And then, of course, you can use programming, which I've been doing lately a lot more of, which is R and Python. So you'll see all kinds of libraries, ggplot and Seaborn and all these other ones, Plotly, that you can bring some incredible resources in to see. And then, of course, there's one here for R. There's one here for Python. They often use the same libraries. And then, of course, we've got good old Power BI. And of course, I'm going to talk about that one because, number one, it's free to use. And number two, it's one I'm the most familiar with. There are others of these out there, and you're welcome to use those and so on. So Power BI is a free tool, lets you visualize very quickly using a drag and drop interface, but it also has a coding language that you can work with it. And so you can go take a peek at those. You can download it, and you can find all the tools and things that you need there. Here's how you install, and here's some steps to learn Power BI. Highly recommended. Once again, even if you're a database administrator or developer and you're not going to do visualizations, it's a great idea to learn these, because if you don't, the people that are consuming what you create are going to come to you with questions. And if you know what they're doing, it's a little easier to work. All right. This is the book, one of the few books that's non-free. It's Microsoft, and I've got Excel 2019. You can get a newer version. I think he's keeping it up to date. This is a fantastic resource. Let me make sure this link is still good. I'm going to open this up, make sure, and it may even say there's a new version out. Yeah, there's a new version of this book here. Looks like it 2021, so there's a big deal here. But this is one of the best books I have ever. It's one of the few books. I don't keep a lot of paper books around. It's one of the few books I keep around. This one is just so useful. I can't say enough about it. Wayne has done an amazing job. I've pushed it everywhere I go. And again, it's one of the few I actually pay for, but I really did. This one's also one I keep on my shelf. I've got it right over here. 7 databases in 7 weeks. And it will take you through, as it says, 7 databases in 7 weeks. And it will take you through a relational database and each of the NoSQL databases with a canonical real-world example of an application that you write, and everything's right there. How you download it, how you install it, what you do with it. Highly recommended if you're a data professional to do that. Wow. Okay. We're off. That was just the tools part. Now we need to go analyze the data in context. Another incredible part. Now that second module that we looked at there that dealt with the tools, while that's super important, and I want high school kids to know how to do that. I want CEOs to know how to use Excel properly. The other modules, understanding that authoritative data is like so critical in today's world. And then this third one here, how to analyze it in context, is a big deal. So when we start thinking about that, we talk about any kind of if you need to do analysis, if you want to call yourself an analyst, you only need to know 6 things. These 6 things right here. Gathering and verifying the data. All this gets documented because it's a scientific process. Homogenize the data if needed. Homogenize means to make the same. to ensure the consistent groupings and things. So if you call it an apple and someone else calls it something else, you can put it and say, no, that word means apple. So I've got two apples, even though they called it something else. You can do that in the data if you document why and how you did that. You group it into meaningful sets, like these apples are in my food group or what I eat during the day or nutritional values or what happens to be. Then you start looking at the data. First thing I do is I just start looking at the data. I try to derive the context, and that's what we're going to talk about here. And then you say, okay, this gives me a result. I have two apples. The daily guidance says that you eat one serving of fruit a day. That's double the amount of fruit I need for the day. Let's say, I don't know if that's true, but basically that's this. Then when you're done, you're actually going to make an analysis. We have too much fruit in the house. That's the analysis part. Now, we often don't go to what's called prescriptive things, meaning get rid of the fruit. That's normally left up to someone else. But the analysis part is where we say, here are the facts. Here's what the facts mean. When they take on meaning, you're moving further and further from the truth because we are subjective human beings. We're not objective. We don't look at things from the outside. We look at them from our vantage point. And so we need to think about that as well. All right, understand. What does the word context mean? Basically, let me just come down here. The key to finding context is using multiple resources. That is the number one thing about finding context. Jimmy hit me. Okay, come here, Jimmy. Tell me more about, did you hit Billy? No, I didn't hit Billy. Diane, can you come over here a minute? Did he hit Billy? And you start getting more and more information, and that'll provide better context for the Jimmy hit me. And then you'll start figuring out, is there a truth here? Is there not a truth here? It's the same with data. You just make sure you involve as many resources as you possibly can, and you'll find that. So I'll basically to give you an exercise to do that. And then we start talking about the biases. Now, one of the things we need to think about here is that we all have bias. We all have bias, no matter what. You all have bias. You can only exist inside your own world, and that is going to bias, meaning to choose. BI means one of two. So we're going to choose our view or something else. So we're always going to choose our own view. And I've got a whole bunch of cognitive biases that you can see here. This particular tool you can find on Wikimedia Commons, and it's got the chart. And one of the things I wanted to show you about this chart is, let's say, for instance, let's go grab one of these. We notice things already primed in memory or repeated often. What this will do is let you go find the one that you are interested in. Look how many biases we have, and click on it. And then you'll go learn about what the base rate fallacy is. It is unbelievable when you start looking. It's almost sad in a way when I start looking through these tons of cognitive biases that are out there, how many I have. And you almost can't look at social media or the news ever again because you just see these over and over. I tend to go over them periodically once a month just to make sure I'm not doing the wrong thing here. All right, so definitely do that. I've got this cognitive biases, so I'm going to show you this one. And why is this important in data? Because before you analyze stuff, you better know that you're not applying a bias toward it. Here's another view of these different biases. And a lot of these, this is one of the main ones, is the availability heuristic. And basically, it's the latest thing that happened to us or the things we know. We tend, I don't like this because, well, maybe somebody never prepared it correctly. And so the availability biases you have, you only had bad versions of those, right? And so you need to break out of that bias by trying other ones, or at least listening to different opinions on that. So definitely take a look and do this. I highly want you to do this. Then we talk about logic. And if you've not dealt with logic before, you remember the A equals B, B equals C, therefore A equals C. You remember those from high school? And so those kind of things you need to understand here, the logic there. And this talks about some logical fallacies. Let's take a look at one of those. These are the logical fallacies. There's formals and syllogistic. And there's all kinds of things you can do here. You'll get into, this will take you all the way back to when we were finding our authoritative data. So very important to do there. And then another thought here is critical thinking. And critical thinking is highly important. I'm not going to drill down on that, but if I'm surprised this isn't a formal class that needs to be taught and must be taught in high school or college before you graduate. But sadly, it's often an elective or not even talked about. All right. We're on the final topic here. We've done all this work around finding authoritative data, using the tools to work with it, understanding how to analyze it properly. And by the way, we're moving very quickly here. There's way more in each of these modules that you should be working through, but I'm just showing you the overall process here. And then finally, we do what we sort of came for, which is using data for intelligent decisions. There's the old adage that knowledge is knowing that tomatoes are technically a fruit, the way that they're with the skin and the seeds and the flesh, they're a fruit. But wisdom is knowing not to put a tomato in a fruit salad. So it's this application of knowledge that becomes super important. And that's where the OpenAI stuff and all the rest of this, the generative stuff, will fall down a bit. They don't have wisdom, they've got knowledge. And so we still need to have that wisdom. I go over an interesting thing where I talk about a guy named John Boyd, and I do this quite a bit, this particular method. He was brought in the military during the Vietnam War in the U.S., and he wasn't a soldier, didn't want to do those kind of things, an analyst kind of guy. He's a very logical thinking kind of guy. So they basically just put him on a problem. They said, we're losing people right and left in war. Can you help us understand what's happening? And what he found out was people were trained heavily, but then in the heat of combat, they made bad decisions. And so he created something called an OODA, OODA loop, which I use to this day. The interesting thing about the OODA loop is that it's so simple it can be used in seconds, and it's so complete it can be used for months or years, decisions that take a very long time. And it works like this: observe, orient, decide, and then act. So you come out of the plane and someone's shooting at you, you just want to start shooting back, but you end up shooting your own people. And so the idea there is first observe what's happening. Just stop what's happening. And then orient yourself. Oh, it looks like the problem's coming from over there. And then decide, I'm going to lay down here, and then act. Now, you can do that in a matter of seconds, or you can spend a great deal of time when your boss says, we need this new project. And you go, okay, tell me more, observe, right? And then who's asking us for this? Okay. And then why are they asking us to do this? Okay, great. All right. So I know where we're at and I know what they want us to do. Let's decide. Let's make a decision matrix and start figuring out how to decide it. Now let's act, rather than what do you want me to start coding, which is what happens a lot, surprisingly. All right. So we really like this idea of this OODAs. You've already done sort of the first two O's of the OODA loop by making sure you've gotten the correct data and making sure that you're using it in context. Now we need to make the decision, the D part. And the first place to understand is the problem itself. Interestingly enough, in data science, I wrote an article one time called The Hardest Thing in Data Science. It's not algorithms. It's not stats. It's not calculating a gradient descent or finding a sigmoid function for your inputs. That's not the hard part. That can be learned. The biggest part is trying to get people to tell you what the real problem is. And there's a whole set of stories I can tell you around people asking me something, you do it, and then they're like, well, no, I wanted this. And you're like, oh, no. And all of you have probably gone through something like that. So I talked to you about how you can develop some clarifying questions, how you can not be terrible and irritating, but still get the person to tell you exactly what they're trying to accomplish. What would you do if you knew that? Or what would you do differently if you knew that sort of thing? And so that's there. And then you need, once you've got all that information, we've got our OODA done, we need to apply the proper analysis to the problem. There's two objectives. I need to discover a set of data that needs to be surfaced, or I need a question that needs to be answered. I need to go find something, or I need to answer a question. Those are the two things you're going to do. And so this is what we're thinking about. So for instance, you could form a decision. For instance, the question revolves around who should we target this advertising campaign? It's a common one. Most of us have that. We want to get our word out about something, an event, a service, a product, whatever it is. So the first thing is, what do we offer? Okay, who normally gets those things? Why did I buy ours over somebody else's? Who should be buying our service and who isn't? And then why are they not doing that? And so on. So these clarifying questions can help you get oriented properly, part of our OODA loop, before you just start making flyers to hand out at the mall or wherever people hand out flyers these days, and so on. You're going to find a whole bunch of questions that you'll develop. And here's basically a process I've developed that explains what you need to do that. Create the goal question, the sub-questions for the goal, source the data for the sub-questions, combine the answers to create a possible direction, score those, and then consider the constraints you're under and choose the highest scoring solution. And you can do this in a spreadsheet. You can actually put it in a spreadsheet and have columns of these and give them a number, and then just do an addition, and whichever one gets the highest number, that's what you do. And when somebody says, why are you doing that? You say, well, here's why. And you can give them a decision matrix that works out really well. We talk again about the importance of data quality and the data types and so on. You want to make sure of that. I worked at the Space Center for a while, for a few years. And when the Hubble Space Telescope got launched, it was a triumph and a marvel. But it turns out that two measurements were used incorrectly. One was in imperial units and the other was in metric units. Normally at NASA, we only used metric, but some imperial units got used. And it turns out the Hubble couldn't see anything. It was very blurry and they didn't know what to do. So we did an OODA, and we decided let's fly somebody up there and let's put some glasses on it. And that's exactly what we did. And if we had followed the right process, this one right here, a very basic boo-boo, if we had followed that, we wouldn't have had to send $1 million mission up to put glasses on a space telegram. All right, here we go. This is true for all of this. Understanding there's a thing called decision science. So I've got a full course for you. I think that one is still free. Let's make sure. Yeah, this one's still free. It's from edX, self-paced. Highly recommended. Put these on your LinkedIn, by the way. Make sure people know that you've taken these courses and so on. And then the other thing I want to make sure you understand is before you start any data project is to consider what alternatives you have. You always want to make sure that, because once we get on a course of action, we kind of fall in love with that course of action. We say, this is what we're doing. This is what we're doing. And in fact, that we shouldn't be doing that. So you should always look at what else could we do and why aren't we doing it? Why aren't we doing that? And if you can't come up with a good reason, then don't do your thing, do the other thing. Make sure you understand what that. And I get that. I get there's time and there's money involved in things. Just go in eyes open and you can put that on your decision matrix. So later when somebody goes, why did we even do this? You say, well, I'll tell you why, because of the thing. That's why we did it. All right. And here's a reference for how to come up with alternative conclusions. When you're all done, it's important to be able to explain what you've done. You have to explain more about why did you take that decision? What is the analysis you followed? It needs to be reproducible. This is part of the scientific process, and it's something that rarely gets done because the minute we're done with something, somebody gives us something else to do, and we've got too much work. Build it in your project plan at the very beginning that you need to do a post-mortem, that when you're finished, you go in and document all your decisions, why you took them and how you took them. And I've got another reference for you to do that. And then finally, as part of that postmortem, and I explain, by the way, how to do a postmortem. There's actually a reference on how to do them. You need to learn from your mistakes. You're going to make mistakes. You are going to make mistakes. It's going to happen. It's unavoidable. And so the question is, and I was told my daughter this as well, it's not a failure unless you didn't learn from the mistake. We don't have failures, we have mistakes. And if you don't learn from them and you do them again and you haven't learned anything, that's a failure. So don't fail. Make sure you just make mistakes and you go from that. Keep in mind, even some of the best sports players in the world only are at 75% efficiency. Every ball they throw, every goal they try to make, whatever it happens to be, the best in the world still fail 1 out of every 4 tries. So you're not the best in the world, neither am I at these things. So we're going to fail. We have to accept that. We have to talk about what we can do when we fail. And we learn and we document that and we try to get better as we go. Well, it's been an interesting study here. There's a couple of things in here that I wanted to show at the very end here. The Society of Professional Journalist and fact checking, think like a journalist. It's a sad commentary, and I'm going to go ahead and stop the sharing. Oh, I do want to show you. Hold on just a second. Let me open. Let's do WordPad, which we're now apparently getting rid of. I don't know if you've heard that at Microsoft, but we're getting rid of that. aka.ms/bw-presentations, and let me make that spelled correctly first, and then I'll make it bigger. That link right there, aka.ms bw presentations, and I'll let you scribble that down. Let me give you a moment here. Let you scribble that down. bw presentations, aka.ms BW presentations. All right. Hopefully you've got that. I'll bring it back up here as I'm talking at the end. I actually won't cut my screen sharing off, but if you go to that, then you'll come here to this, and let me zoom in for you a little bit. And if you come down here, you'll see under notebooks and courses, there's a whole bunch of things here about data literacy and things like that. That's the course you just saw. Okay, let me pop up that reference so you can look at it while I'm finalizing here and see it. Hopefully you can see that. Okay, I'll make it even bigger. Let me scroll over if I can scroll over. All right. It's terrible. Look at all this technology I've got, and I show this like this. All right. So let's finish up. It's a sad commentary that we don't have the rigor that we once had inside our news. NEWS, new things, or Northeast, West, and South is what that's often been called. But the idea is in our news, everyone can do it now. Everyone's got a platform. And so there's less critical thinking. There's less verification that we see. We used to outsource our verification to people who were paid well to do this. Those people are not paid well anymore. And those sources have slowly been strangled by the competition of the internet. And so we're not getting as vigorous a process as we could. But you would do well to go to those last two links in the course and learn to think like a actual paid journalist. And you will learn so much about finding out information within your projects. All right, let's close out with this. Why do you need to know this? It's very important that you're data literate. It's important that our children, not mine, not yours, everybody's, are data literate in today's world. And it's important that you know how to do these things so that you can share this knowledge. Once again, thank you so much for having me. I wish I could be there in person. I used to live in Asheville, North Carolina, nearer to you all than I do here in Florida. But one day maybe we'll be back in person together. So thanks again to the organizers for all they do, but for inviting me today. Really appreciate it.